So we have a lot of objectives there for eNanoMapper, but really one of the fundamental one is how do we organize and describe the data in a good way? How can we sustain data from the different projects? And just like we've seen in other areas, like in the area of alternatives, like we saw in ToxBank, there really is a lack of data science practice in a lot of labs and in a lot of projects, and we're suffering in terms of quality. We don't, this goal we have of interoperability between databases, we really struggle on that. I think it's still something very worth working on as a goal in this area. And a lot of projects organize their data independently, and the project finishes, and it's very difficult to do meta-analysis. There's no plan for sustainability. A lot of data gets lost, and so forth. So that was one of the motivations for eNanoMapper. Could we sort that out? The answer, of course, is probably not, but we've tried to make some progress in this area for this cluster of projects, and to sustain eNanoMapper by organizing that data within a community context over the longer term, and then to build interactions around that. So one sort of simplistic view we have on that is we really need to start, like Thomas just said, with the planning of the experiments, experimental design, and thinking about the end use much further downstream of that data, not only by modelers, but the practical application of this information really should be driven by thinking about the case studies when someone in industry is designing a product, or a regulator needs to do a risk assessment, and often those groups of people don't really know each other, and so it's quite depressing at the end when you sit down with a case study, even in a chemical risk assessment, and often find that there's just not a lot of information available to even think about the key event or know about it. So the eNanoMapper has put quite a bit of effort, like we have done in ToxBank, to starting to define the templates and the metadata describing the experiments, and to see if we can get some kind of better agreement on what those templates should be, and what the ontologies are that then support the development of those templates and the capturing of that data. And then we have to solve the problem of getting the data into the system and hosted either locally or federated and shared within the community in a more effective way than we're currently doing. And then to be able to combine it with other useful data. Again, when you want to go and do a risk analysis on a particular situation, you would like to be able to bring in all possible available information, all valuable evidence to your analysis. And that's often quite difficult, so we need to keep that in mind. And then to provide long-term access to the information that's organized in a better quality way. So that's sort of been a fundamental goal of the project. And with that, the interaction within the community with the other projects, I think has been a very important ingredient, because that's really defined the use cases within the community of different activities, including what a lot of the experimental labs are doing, that provides us the use cases to drive how we should focus our work on organizing data and defining ontology. And obviously the ontology development required for something like OpenTox or even like eNanoMapper is actually a huge effort. So I think use cases driving the ontology we really need for the applications we have to program it gives us that focus that we can make it more something we can get our hands on and make progress in the area. So the ontology is practical and has impact on on cases like integrated analysis or risk assessment. So if you want to take a look at some of the resources we're developing, you just go to that eNanoMapper net portal, and that's something we're, through a variety of means, sustaining as a resource and providing assurance, like we're doing on ToxBank, that this kind of set of resources will sustain beyond the initial project. And we're quite confident, at least giving a 5-year sustainability guarantee on what we've been developing on these projects, and that it's not going to go away at the end of the project. Because an effort like ontology development, like we have here, which I think even earlier this year was over 10,000 classes, it's something we need to figure out solutions on how do we keep building on it, sustaining it, maintaining it, updating it. It's not a solved problem, but we've made, I think, a lot of progress so far. This is, of course, in an OpenTox kind of way being made available. You can take a look at it, in the Protege browser, or go to download the most recent version from BioPortal. When you look at the API work that's been developed and the documentation of it, you can make use of that then in your own applications. And importantly, what we really value as well is any groups that have an interest in identifying weaknesses in the interfaces or the ontologies that are used there, or gaps. That's a very valuable contribution to keep improving it. So by making this open, it's available to improvement and criticism. And the eNanoMapper database developed by Nina in terms of extending ambit to nanosafety is available online, but also as a downloadable solution in terms of either data sets or the full database itself, so it can be installed as a local solution. And of course, what's one of the returns we might get out of all this work in trying to improve the quality and how data is described? Well, the case is very simple. We want to make it easier for people to find and to access and use, and there's a lot of and the situation I think was so poor we could only make some progress on it. Some problems, some legacy problems we can't solve, but we can at least provide access by as many people into the community as possible to what data is available. But more looking towards the future, in the context of projects like NanoRate that are generating quite substantial data sets currently, is the need to solve the data input problem. In other words, having a sufficient discussion to agree on how the data needs to be described, including the metadata, and how we get it into a system, which may be from a machine, maybe through APIs, it may be through labs that will continue, like a lot of biologists want to do, to work with Excel, but then how do we get that into the system? So I think there's no one solution. We're working on different kinds of solutions. The ISA tab was mentioned by Thomas in the last talk. We've done a lot of work on that. It is a lot of work, and we need tools to make this more user-friendly to most labs, most researchers. It's too much for them. It takes too much time. It's too complicated. So we need a development of tools and collaborations again, I would say, between data scientists and these experimental labs to describe the metadata in a better way. Of course, you're using ontology when you're defining your templates using this isotet or the nano extensions of it. So how do we make this user-friendly enough so that we can help motivate the getting the data into the system? Once it's in the system, though, at least then we can provide a well-described data set. So if you do come in and download data set and you're looking at analysis of it, at least you should understand clearly what that data is, and that's not so trivial in an area where there's a lot of subtleties in how the protocols were used to generate different data, and you may not even realize some of the variations in protocols that perhaps would invalidate a combination. You can go and take a look at the database solution that's available online, and there's a couple of publications on it. We heard from Georgios about the modeling infrastructure development. Again, like with an OpenTox principle, that the modeling infrastructure should be interoperable with the sources of data that are coming into the applications. This nice one on calculating descriptors automatically from images, I think, is a very nice one. And we see there's going to be not just a growth in in omics data, but probably a lot more high content imaging data. So a lot of functional mechanistic insights are going to come from increasing amount of video and images on an increasing number of cell lines. So I think this area of processing all this biological image data into descriptors for models is a very promising one. And especially when we don't understand these mechanisms in many cases. There's also a read-across application we used to look at with Christoph in the workshop yesterday, and the depressing news is there's just so little data available when you actually come down to building good models. It's really quite I say depressing when you realize how little data is actually available for building a reasonable model. So, but in any case, you can take a look at his extensions of Lazar to read across from these GitHub references. We've also been trying to develop materials to make what we're building more understandable. I think this communications effort is really important as we try and build a larger community around the effort. So tutorials that describe with videos and examples how to actually use it. So please go there, and if you're trying to use one of the applications like we just described, hopefully they would help you use it. So I'd like to go back to the thought that the importance of us being a knowledge community and building a knowledge infrastructure. Because beyond all of what I just discussed with data and ontology and the modeling work that's needed, at the end of the day, we need to bring knowledge together, which is often a set of expertise and a particular case study situation, a situation where we need to make a decision, where we need to form a judgment. And you have to make the best use of all available evidence to make the best decision that you can. So I think there's, in terms of our advancing the impact of what we're doing, this is an important aspect to keep in mind, that in the end, decisions are not made by models. If somebody's working on a risk assessment, they basically look to access high quality evidence and think about it and discuss it and then try to come to some kind of judgment. So this interaction we're having within the context of European American cooperation, where I'm serving on the data modeling community of research. We have like both US and European sides. This project, I think, has been a very interesting one for us that we want to do more work on. And we're interacting there with a risk assessment group, defining case studies, and then trying to bring the evidence together when we bring the different disciplines, there's 7 different communities of research, then we try and put what we know about the nanoparticles and their chemistry and any information we have on the table and discuss it together and try to work our way through a set of questions. So we just had a workshop like this in Arlington in June, and it'll probably come back. The next one will be in Europe next year. And in this one, we also sort of had a gaming aspect of it, so that there were different teams, and at the end they had to face like a press conference and just sort of defend as best they could what they thought the best decisions were in these kinds of crisis situations. And so one of the integrating applications that we started work on and that we've used now in a couple of workshops, and I think is quite valuable, is the idea of having an application that through a variety of means brings all the relevant supporting information for such a discussion and decision making together around such a set of case studies and their discussion of them in a sort of a workshop format, which might vary. In this one, it's very much with teams and a challenge, and there was a briefing, and then people had to work together on. And as they work through the questions, then the application should provide them any supporting evidence. In an OpenTox way, if someone had a question, they could pull in a relevant piece of data quickly and effectively, because you don't want to interrupt the challenge and the conversation. So one feature that we've worked on with that is that then the group, both before, during, and after perhaps the workshop activity, could all contribute to evidence that they could locate or citate and add to in a group sort of manner to the evidence around the case study. And we'd also like to be able to go out to any relevant sources of information, resources from projects or public, large public resources, and bring that evidence in, with approaches like from text mining and so forth. So a goal we have on that to work on with the road mapping and planning that's going on in this area would be, could we also bring that evidence against these roadmaps and show where there are gaps? So we have case studies that can map to the different areas of science that we need to do this safety assessment. We also need to take a look at, well, in this sort of area of information we need, it's actually quite good, but in this area where we're trying to build, say, a QSAR for a particular kind of nanotechnology, then we have a lot of issues, like Thomas pointed out, and that should really drive clearly the information we need, for that decision-making purpose should go into the roadmap, and that's what we really need to fund in upcoming projects. I'm not going to go into detail, but I think a very important aspect of eNanoMapper that will be part of its sustainability into further projects are the interactions. Again, that eNanoMapper, we haven't taken the approach of being an isolated project. We've been very interactive. We've talked to all the other projects in this area and come up with some kind of value proposition that we could interact with. Sometimes a small step, but that's that's the way you make progress. And NanoReg is an example of quite a large amount of work. I think it's close to 100 templates that we're working on, and eNanoMapper will be a sustainability for the data from that large regulatory science project. It's also been interesting to interact with projects like Sun and Guide now that are developing risk assessment tools, and it really starts getting to think about, well, what is the information needed by those sorts of decision-making tools they're developing. And the importance for joining standards bodies over the longer term. One problem we faced there as well is, I think, if we're going to have more collaboration, say between the modeling community and the data science community, it would be really great if we could make it easier to bring people together more quickly. Some of these collaboration agreements between projects generating data and say a project like ours that could help their project take too long. So some of the barriers are various kinds of legal or administrative barriers, I think, to the progress. So we've been trying to grapple with that. And then, like we're doing with ToxBank, to say to the community, we're going to sustain this as a valuable reference resource and continue to improve it as part of OpenTox over the longer term. It's not going away. So the same thing with what we're doing on eNanoMapper. So just to finish up, so this is an old slide. You've seen me show at OpenTox meetings before, just so we don't forget our history. It goes back to, I think, our first demonstrations in Berlin a few years ago. And we have done a lot of work interacting with experimentalists on this problem of describing experiments and working with ISA and templates and thinking about what would be the updates needed to the definitions. So when we talk later in our organizational meeting about the future, this is kind of a topic's been kicking around for a while, and you can see there's a number of different efforts going on now on how we should update and our thinking on what do we do in terms of APIs. But one suggestion might be, let's really think about where would be the most value if we really could achieve, say, resource interoperability for the data that will really be valuable for both scientific and risk assessment purposes, and really make that work so we could retrieve and integrate information in a more reliable way. I think that would give a large number of different stakeholders and communities great value. So perhaps that's really where we should focus our effort in. And that could be, say, a priority challenge for next year. I mean, the work has also shown, I think, a challenge we still face with OpenTox in terms of the goal of semantic interoperability. We had a workshop on that a few years ago. There's just a tremendous amount of work to be done. And if we're starting to describe knowledge objects like we'll discuss tomorrow, like with key events and AOPs, even more ontology to be developed. And it's really hard work. It takes a lot of time and effort to do these things. So I think in eNanoMapper, with the ontology effort there, it really has been a significant amount of work by Egon and Jana and the others that have developed it. And yet, to sustain it and build upon it, it really is a significant amount of work. It's maybe difficult to get it funded. We were lucky with eNanoMapper, we had a full work package that was funded. But it's still, I think it's still a challenge how we're going to progress this. And so let's keep discussing it. Let's make sure it stays on the roadmap and so forth. Also looking forward with regards to a knowledge infrastructure, I think this area of the modelers sitting down with at the very start of projects, and we need to do this really at the start, not at the end like we currently do, defining the experiments and how the information could be combined with modeling is something where we really need to progress, or you see the situation that we currently have in nanosafety, but I would say also in other areas of predictive toxicology. We still have, I think, a lot of challenges here. We have a lot of data resources, but we can't combine data reliably. We don't have the ontology to combine data. And over here, think we need more interaction in this whole area of data science education. So perhaps what's really needed there for next year as a priority is let's build now on these tools we've been developing, let's build more training activities, let's interact with the young people who are doing the new experiments and the new projects, and try and learn from each other so we can transfer some of the knowledge that, say, data scientists have to experimentalists and vice versa, and have that come into our conferences and workshop activities. Because currently, because we don't have these flows, we're in part of the boxes, but because we're not able to connect the whole cycle of knowledge, a lot of things are getting blocked. Which brings us back to this diagram. To achieve this in nanosafety, and I think in all areas of alternatives and in practical applications for safety assessment, there's still a tremendous amount of work to be done. I think we've been making some nice progress though with this eNanoMapper project, and I think there's a good sort of foundation there to build upon. And this work was carried out by these 9 partners, although we ended up with 8, I think, at the end. I think everyone in this project really contributed a lot of work, and it's been a very hard-working group of people. And I hope that shows in some of the results we just presented. And with that, well, thanks for listening, guys.